G'day viewers, well, I've got an idea. I wonder if I put this and this with a three-phase meter in between. Will a three-phase meter go stupid speeds running at variable frequency as well as just a current or what? It mightn't work at all. It could damage the meter. What could happen? What could happen? Shouldn't damage the meter there. I don't see how it would. The motor can, depending on the bearings I suppose, the bearings in the motor will get some EMF in there and hit the meter eventually depending on the bearings. But for a meter, if I use it, depending on what sort of meter I use, if it's all floated magnetic bearing, there's nowhere for the eddy currents to go. And if the register's got a plastic gear, the eddy currents in the load disc and the whole assembly that moves shouldn't damage anything else. Because in theory, if these are all magnetic bearings, and the plastic is meshed via a plastic gear between the register and the axle of the load wheel, there shouldn't be that pitting problem like you get with bearings and motors on some sorts of bearings. Curious, how will a three-phase meter behave on a variable frequency drive running a motor? Curious. Anyway, here's my next meter. 2.5 to 15 amp current transformer. I don't want to put any more than 15 amps to this one, so it's going to be a slow test. Raymond, or Act 2007's had that problem, is smoked the left coil out of his SDM. So if you can short it out, you could just re-varnish and she should be okay. Anyway, let's test this one. This and the also needs some extra wires to wire up the potential coils separately. Bit of a derp moment here, viewers. A big derp. All those CT meters I've got. Instead of just doing this, I could just go get some spare bolts and screw them in there and use these to connect the potential coils instead of doing this. All those digital electronic ones I've ripped apart and got these bolts out. I'm going to use them for here. Just whack these in, put them back in. The way it electrically connects the main active to the potential coils instead of doing it this way. That's just too messy. So I've got to get the terminal screw stockpile out, which is what I should have done. And just put screws in all these holes to connect the potential coils up like normal. Oh, let's test this device. Clamp here, there it is on 0, double check. Now it's hard to connect this onto such small terminal blocks. So I've got the wires just in there enough. They may burn out, but rather that than the meter. I've got to get that on 3 so it'll be on the 4 when it finishes. 15 amps. She's fully loaded. Alright, this meter's fully loaded. As fast as it goes. Actually, look how fast that dial's moving. Yeah, actually CT meters are going to divide, don't I? Dull. Now I think it's 1 kilowatt hour and it's gone 100 watt hours on this Iskra. Well, that's sort of, I forgot how to divide, so CT meters are very challenging here. It looks like I divided by 10, do I? It's 1 kilowatt hour and it's gone 100 watt hours, so I might have to divide this reading by 10. If that's the case, I've got 100 watt hours registered so far and 1 kilowatt hour registered, so looks like it's accurate. I'm just going to divide the reading. 155/6. Yeah, let this thing do 1 kilowatt hour. I'll keep an eye. I reckon we'll get about, let's see, yeah, but it's going to take a while. It's 100 watt hours. I got to divide. Quite a challenging one actually. I think it'll be easier if I get the CTs out of my, get the current transformers out of storage and wire this up correctly using the current transformers. That'll be the best way to test this thing for accuracy. I've got the CTs to do it now. I should just do that. 6.6 revs per kilowatt hour. And the next one, 6.66 reds per kilowatt hour. Also a CT, the dual tariff one after it. It'll probably be the same, it'll go the same way. Wires up the same way, so I've got to use a CT to these ones. Make it a lot easier for me. There you go, it's fully loaded at 15 amps. The ISCO's turning very slowly. Turn that off, zero it off, unplug safety first. I'm going to save these CT ones, I'll clean them up anyway and just do them with the current transformers, it'll be easier. Let's clean it up and I'll do the other one after this one just for the sake of it. Oh, this one's all nice and clean. It was recalibrated in 1981. Cleaned right up very well. Yeah, I've got to go dig out my current transformers in order to test these properly. There we are, clean it very well. Thanks for watching.